Another example of a combinational circuit is a multiplexer. So multiplexer is a opposite of a decoder and similar to encoder, but it's a little bit different. So the decoder, encoder, multiplexer, another one demultiplexer, that's a little bit confusing terms. Here, multiplexer is one of the input is connected to one single output depending on control lines. That's a multiplexer. Just imagine if four guys are running into one lane, then which one you wanna pass. So establish connection from input to one single output depending on the control signal. So that is a multiplexer. So the size of the multiplexer is determined as follows. So if you have n inputs, then you should have control lines. Log 2n should be there. Output is always 1. So if we say n to 1 multiplexer, n is the number of inputs, and then out of n we can compute log 2n, and then that becomes a number of control lines. So this example, we have 4 inputs, and then control lines should be log 2 4, which is 2. So we have 2 control lines. Depending on control line value, if control lines are 0, 0, then I0 is directly connected to output and all the others are not connected, disconnected. If control lines is 0, 1, then I1 is connected. Similarly, 1, 0, I2 is connected, 1, 1, I3 is connected. So that's a multiplexer. So here is a simple implementation of a 4 to 1 multiplexer. So we have 4 inputs in the 1 output multiplexer. Then we need a log 2n, which is 4. So we need 2 control lines. So we have 2 control lines here. Depending on the control line value, output is connected one of 4 inputs. So if we have a selection line 0, 0, 0 means this line is 0. So one of the input is 0, then output is always 0. So output is quite blocked. And then next one comes from 1 as well. So this output is blocked. And then next one comes from inversion of S1, so output is, this is okay. But the next line, this line says it comes from S0. Since S0 is 0, so this is blocked. But the last AND gate, so this input comes from S1 not. So S is 0, S1 not is 1. So this is a 1. And the next input is from S0 not. So this one input is a 1 as well. So in 3 input AND gate, this input is a 1 and this input is a 1. Then output of this gate is determined by the remaining input. If this input is a 1, output is a 1. If this input is 0, output is 0. So virtually, if I give a 0 and 0 in select line, I0 is connected to output. All others are AND gate output is all zeros. So all others are, it's not affecting the output at all. So similarly, if I have input 0 and 1, then 0 is connected to this gate. So this gate, AND gate output is always 0. It's blocked. And then this one is connected to this line as well. So this output is always 0, virtually disconnected. And then this line comes from S1 not. So this is 1. So output is not blocked yet. And then next input is from S0, which is 1. So this gate is not blocked. So middle input comes from I1. So if I1 is a 1, output is a 1. I1 is 0, output is 0. So this AND gate output is determined by I1. So this one goes to OR gate. And then the very last one This input is okay coming from S1. However, this input comes from S0 not. Currently S0 is 1, so this one is 0. Output is virtually blocked. So this selection I1 is passed. Similarly, if I give 1 0, this input is up forwarded 1 1, and then I3 is forwarded. So this is implementation of a 4 to 1 multiplexer.